Hello, my name is Arkadii. I'm a software engineer at Google, and some of you may know me as a creator of libraries like Decompose or MVI Kotlin. And as a library developer, I've faced some challenges with keeping the library API compatible when adding new features or fixing bugs. And in this talk, I will share my experience. We'll go through a bit of theory first, and then I will show some examples with explanations and solutions. But before that, I would like to give a small disclaimer. So even though I work for Google, I'm doing this talk on my own capacity and related to my employment or role, and all opinions are my own. So first of all, a bit of theory. Let's first define what is an API. An API, an application programming interface, is a way of two or more computer programs or components to communicate with each other. So if we have, let's say, two classes, one is internal, one is public, each class may have their own public APIs. So there is API of an internal class and API of a public class. An API of internal class is always safe to change, but the API of the public class is not always safe. So an API is safe to change if we can also update all its clients. And usually we go through something like this flow. When we want to change an API, we first should answer one single question, whether we can update all clients. So if the answer is yes, then we can just change the API and don't forget to update all clients. This is the case, for example, if the class is internal, or if our library is published internally somewhere in our private repository in our company. In this case, we are free to break the API if you also going to update all clients all using modules, consuming modules. But if it's not the case and the answer is no, then we can change the API, but we should do it with caution. So there is forward and backward compatibility. An API is forward compatible if we can downgrade the API version without changing the clients. An API is backward compatible if we can upgrade the API version without changing the clients. There's also very nice and useful spec. It's called semantic versioning, or SEMVer. It's used by many libraries, including, let's say, Jetpack libraries. And it's a spec that it's quite a big spec and very useful, so I will provide all the links in the end. But its main point is that there are three parts of the version number, which is major, minor, and patch. And we increment the major version, we are making incompatible API changes. We increment the minor version, we will make only compatible changes, and we add new functionality. And we increment the patch version when we don't change the API and just fixing some bugs in a backward compatible way, of course. So as a library developers, we don't usually care about forward compatibility, but we do care about backward compatibility. And there's also such a concept as a source and binary compatibility. An API change is source compatible if the client code still compiles on upgrade. An API change is binary compatible if the client binaries already compiled with the older version, they also work at runtime when there is a new version. So let's talk a bit about binary compatibility. So if we have an app that depends on two libraries, A and B, of version 1, when we package this app into a binary, then in the binary, there is a library A version 1 and the library B on version 1. And everything works as expected, supposed to work. But let's say if in our application we update the library A to version 2, but the library B still depends on version 1, then what happens when we package the library, the application into one binary, we have our application code, we have library A code of version 2, and we have library B code of version 1. And this may break because library B still depends on, treats library A as version 1, and it may do API calls that has been changed. There is also a very useful specification, specifically chapter 13 of Java language specification. It describes many possible changes and explicitly says whether a change is binary compatible or is not binary compatible. And there is also a very nice tool created by JetBrains, which is binary compatibility validator. It's a Gradle plugin that you can add to your Gradle module like this. And once you add it to your Gradle module, you can just run the API dump task. And what this task does is it generates a bunch of API files, text files somewhere in the folder, in the API folder, and you just commit these files to your Git source control. And later, nice music. And later, if you change the API somehow, doesn't matter if it's breaking change or not, your build will fail. And it's an explicit way of saying to you that you changed the API, which might be by accident. So what you do at this point is you run the API dump task again, and you will have all your API files changed, and you can check the diff, and you can manually check whether the change is intentional, whether it's breaking or not. If you are fine with it, you can just commit these API files again, and your build will pass. So let's talk about some real-life examples that personally I faced during my library development. The first one is very simple. We want to add a new argument to a function. Let's say in this case we have a log error method with tag and message strings, and we want to also add an error throwable, which is nullable in this case, optional. Of course, this change is not source compatible because we can have a client that call this function and supplying just 2 arguments. It will not compile anymore. So one of the possible solutions is to provide a default value for the new argument. In this case, let's say that by default it will be the error will be null. This change Test. Do we want to also switch the music off? Maybe. I don't mind. Thank you. Okay, so this change is binary incompatible because if we can see this, if we run the API dump task, we will see this something similar API diff, and essentially it says that the old method got removed with 2 arguments, and there is now a new method with 3 arguments. And according to Java language specification, adding a parameter to a method declaration creates a method with a new signature, and it has combined effect of deleting the method and adding a new one, which is a binary incompatible change. So we can't do this without increasing the major version of the library. What we
Okay, so it's going in every room, and it's not from my board. I asked to stop it. Maybe now they stopped it.
Thank you. Seems like it now off. Okay. So what we can do here is what we should do here is we should annotate the old method as deprecated with level hidden, and we can add new one, and the old one will be just calling the new one. So in this case, our API diff will look like this. So our old method now synthetic, so which means it's still present in the binary and can be called by existing clients already compiled. And there is also a new method. So this ensures binary compatibility. Another use case, if we have our message argument as a lambda, like a function that returns string for lazy evaluation, for example. If we add our error argument after the lambda, we'll break source compatibility because of this. Okay, so clients may be calling this log error function as shown in the example. It will stop compiling. source incompatible change. Quite disturbing. Yeah, if you add error argument between the two, this is also source incompatible because the client may call the function without named arguments as shown on the screen. So in this case, the only possible solution is to just add a new method and keep the old one in the source. So this change is source and binary compatible, of course. Another interesting example, if we want to add a new method to an interface. So of course this change is not source compatible because clients may have like custom implementation and the code will stop compiling. What we can do here is we can specify a body for the function. In this case, let's say our logger by default calls existing log debug. And this is source and binary compatible change. Another trick we can do is if we don't expect clients to implement the logger interface, we can mark this interface as sealed interface, which will prevent clients from implementing it on their side. And the library can provide their own implementation, like let's say default logger. And we can also have our internal class for some internal purposes in the library. And in this case, adding a new, in this case, we can add new methods to the logger without breaking source and binary compatibility. And we don't have to specify body in this case. If you want our logger to be abstract class for some reason, let's say we want it to be stateful, then if we want to prevent clients from extending the class, we can mark its constructor as internal. So adding a new method without a body will be also source and binary compatible. Another example is enum. How do you think if we add a new entry to an enum, will it be breaking change?
Of course.
Yes. So it will be source and binary. It will be source and binary incompatible change because clients may switch the enum exhaustively, which is a feature of Kotlin, and they will stop compiling and they will throw errors at runtime. One of the possible solutions to this is to use value classes with private constructor and a companion object with all possible variants. Let's say we maybe have a constant one known, bad request server error, and we can also add an unauthorized error code there. So clients are forced to use non-exhaustive switch here because all possible ways are not defined at compile time. And so adding a new entry will not break anything here. So this change is compatible. Sealed classes, adding a new entry is compatible or not? Same reason as with enum. Clients may switch exhaustively and will break at runtime, at its compile time as well. So it's incompatible change. One trick we can do here is we can add a private data class entry, let's say not exhaustive. So this will force clients to use non-exhaustive switch because they can't check for not exhaustive data object. And in this case, we can easily add a new entry here. Data classes, they're very tricky. Same with methods, we can't just add a new argument to a data class. It's source incompatible and binary incompatible change. And same if we specify a default value for the argument, it is also going to be incompatible change. If we check the diff, there are two incompatible changes here. The first one is the constructor. It's got replaced with a new one. This is binary incompatible change. And another one is the copy method. It's also got replaced, which is automatically generated by the compiler, and it also got replaced with a new one with two arguments. How do we update our data class in a compatible way? It's very easy. We just add an old constructor with one argument and deprecate it as hidden. And we also replicate the old copy function and also annotate it as hidden. And in this case, we'll see that our constructor now synthetic, and there is a new one, which is binary compatible change. And the copy method also now synthetic, the old one, and the new one is also there, and it's also binary compatible change. So this change is compatible. There is also a very nice article by Jack Wharton, Public API Challenges in Kotlin. It also highlights this tricky cases with data classes, I highly recommend reading it. And don't forget that we have this requires opt-in annotation in standard library. With this, we can create our own annotation class, let's say experimental library API, and we can annotate our APIs in our library so that clients know that this API is yet experimental and it may change at any point, and we don't have to bump major version when we change this API. And it's very useful to test our APIs, receive feedback, and update the API, and eventually promote it to stable. So it's okay to break. And finally, I would like to just provide some tips and hints for library developers. Try to reduce your API surface as much as you can. So only expose things that solve real use cases. Don't try to add everything. It's easier to add a new API than change an existing one. Consider creating superior APIs. Developers can build their own extensions on top of a flexible APIs. And use binary compatibility validator plugin because it prevents accident API changes and simplifies validation of breaking changes. And use experimental opt-in annotations to promote API to stable when you're confident. And follow some step. Go through alpha beta stages before releasing a stable version. And increment major version when you release a breaking change. That's it. I think it's time to conclude the talk, and here are all the links and my Twitter handle if you want to subscribe. Thank you. If you have any questions, I'm happy to answer.